Let's have a look at this problem question from Acids and Bases in the grade 11 physical science syllabus. Pure Na2CO3 is used in a standard solution to determine the concentration of hydrochloric acid by dissolving 0.53 grams of Na2CO3 in water and titrating this against HCl. So as you can see here, we are looking at a titration or acid-base neutralization reaction. We currently see also that we have 0.53 grams of Na2CO3. This is going to be titrated against HCl, and we see that the volume of my acid here is 32.5 cubic centimeters. 32.5 cubic centimeters of the acid is required to reach the end point. The end point is the point where neutralization occurs. So when you do a titration, you'll see that this is the point where the color change of your indicator happens. Our question, calculate the concentration of the acid. So here, this is our unknown concentration of the acid. So before I try to answer this question, I first need to go and write down my chemical equation. Here I see it's HCl plus Na2CO3, which means that this is an example of an acid plus a metal carbonate reaction, which means that I'm going to have a salt form. It will be the Na or sodium, metal, and chlorine. They bond in a 1-to-1 ratio, and then it will also lead to the formation of CO2 and H2O. I need to make sure that this is a balanced reaction before I can continue. So when I look at this, I see I have 2 sodiums on the left-hand side, 1 on the right-hand side. I added 2 in front of Na, and now my chlorine is also 2 on the right-hand side, which means it has to be 2 on the left-hand side. I have 2 hydrogens left and right, and now everything seems to be balanced. I'm also just going to add in the state of each substance. This is diluted, so it will be hydrochloric acid AQ. I know that my sodium carbonate is also in solution. It was given in the question. NaCl will also be soluble in solution. CO2 will be a gas, and we know that water is a liquid. If you don't know why I use L for H2O, please go and have a look at the reactions in aqueous solution video. Now that I have my balanced chemical equation, it helps me to figure out what my next step is. When you don't know what to do, always take what you have to moles. So let's take our 0.53 grams, which is mass, to moles. To take mass to moles, I'm going to use my formula N equals mass over molar mass, and therefore I need the molar mass of Na2CO3. If I use my periodic table, I can easily calculate the molar mass of Na2CO3. It will be 2 times 23 for sodium, plus 12 for carbon, plus 3 times 16 for oxygen, and this is going to give me 106 grams per mole. Substituting this into my formula, 0.53 as my mass, my molar mass 106, and this should give you 0.005 moles of Na2CO3. Now when I go and look at my balanced chemical equation, I see here that I have 2 moles of HCl reacting with 1 mole of Na2CO3. We don't write the 1, but it's implied, and therefore we know our mole ratio here will be 2 to 1. I know that I have 0.005 moles of Na2CO3, and therefore I can make the amount of moles of HCl my unknown, and I'm going to use X. I multiply crisscross, and now I see that X is going to be equal to 2 times 0.005, which gives me 0.01 moles of HCl. Now I have my amount of moles. Remember, this is my N value for HCl. I also have my volume, VA. And if I want to calculate concentration, I know that there is a formula in which I can combine these 3 things. Concentration of an acid is going to equal the amount of moles divided by the volume. Now just be careful, volume has to be in cubic decimeters, because concentration is in mole per cubic decimeter. which means you need to take the 32,5 cubic centimeters and divide it by 1,000. This is going to give you 0,032 cubic decimeters. Now we go and substitute our values into our formula. Our amount of moles 0,01, our volume 0,032, and you can add the 5 just for accuracy's sake. And this is going to give you a value of 0,31 mole per cubic decimeter, or instead of using this unit, you can use capital M. And remember, this is now the concentration of my HCl.